In this video, we are going to study about the Unit 2 of Basic Electrical Electronics and Measurements. In the Unit 2, we are going to see about the electrical machines like transformer, generators and motors. Based on the law of conservation of energy, energy can neither be created nor destroyed. So we can create a new energy from nature. Hence, an energy conversion process is required. Suppose if you want an electrical output, then we need some other input like heat energy or thermal energy or light energy or mechanical energy. So, if you want any energy, so we need some other energy as input. In this unit, we are going to see about generators, motors and transformers. Generators convert mechanical energy into electrical energy. The electrical energy may be DC or AC. If it is a DC output means when it is a DC generator, AC output then AC generator. Motors convert electrical energy to mechanical energy. Transformers are used to changes the voltage level. It steps up or step down the voltage level of the AC output. Let us see the important tabs. First, flux. Flux means these are the magnetic lines of force. When you bring a iron piece to near a magnet, then at a particular distance, magnetic lines of force produced. That is the flux. Next one is the reluctance. Reluctance is the opposition of flux. So the opposition of the flux factor is called reluctance. Next one is the electromotive force. Electromotive force EMF, that is the force required for the flow of electrons. Flow of electrons means current. So the force required for the flow of current, that is called EMF, which is the voltage potential. And then now let us see about the parts of DC generator. So this is the DC generator. So here the parts are magnetic frame and yoke. This part, this outer covering part is called the magnetic frame or yoke. And next one is the pole cores and pole shoes. The pole cores and pole shoes are here. It may be electromagnet or it may be a permanent magnet. And then the coils wound in this pole cores are called pole coils or field coils. And the rotating part, this is the armature. Here the armature, the windings wound in this armature is the armature winding. And this is the commutator. And here brushes are present, brushes, the bearings. These are all the parts of the DC generators. Let us study all these things one by one. Here, this is the DC generator. While drawing the exams, you have to draw like this. So, this is the frame yoke, this part, and this is the field poles. Here, this part is the pole shoes. You can say this is pole cores or field poles. Here, this is the pole shoes, and this is the windings wound in the pole. And now, this part, this is the armature. In armature, here this part is the teeth, this is the slots. In the slots, the armature windings are wound. This is the armature winding. And the center commutator is present. And this is the shaft. So these are all the parts. And let us see the parts one by one. This is the outer frame or yoke. So this provides the mechanical support to this machine, and also it acts as a protective cover. It protects. It carries the magnetic flux produced by the poles. Here only the poles will present in this area. So this one carries the magnetic flux produced by the poles. And it is made up of cast iron or cast steel. Small machines are made up of cast iron. In this case, here the main consideration is taken as the cheapness. And in large machines, cast steel or rolled steel are used. Here the weight is the main consideration. In small machines, a single piece yoke is produced. But in large machines, two piece, that is split yoke. This yoke will be divided into two, the split yoke is present. That's all about the magnetic frame or yoke. The next part is pole cores and pole shoes. His pole cores or pole shoes are attached to the magnetic frame or yoke. Here, these pole cores, it may be a permanent magnet or it may be electromagnet. Electromagnet, we have to wind the coils. We have to, the coils are present. We have to give supply to the coils in order to make it as an electromagnet. And this pole core, it may be a single piece. Here see, it is a single piece. And this may be a laminated pole core. Laminated pole core is several segments of sheets are laminated and then attached. These are, here you can see small lines, that is several sheets are present and they are attached with insulation. Laminations are used to reduce the eddy current loss. In order to reduce the losses, laminations are present. Okay. Now here this is the pole shoes. This part. Here this part. So pole core may be a solid piece or laminated one. Pole shoes always it will be a laminated. Here the pole shoe part is laminated. Here also it is laminated. What is the use of pole shoes means? It will spread the flux. Here the nature is like this. Here we are giving supply. So this the coils will wound here. Will be wound here. So automatically when current goes to this coil, the magnetic field is produced. So this flux produced in this will spread out through this pole shoes. So that is the function of the pole shoe. It spreads the flux in the air gap. This pole shoe spreads the flux and that this pore course directs the flux through the air gap. And also this pore course carries the field windings wound in the carries the field. This pore course also support the field coils. This pole shoes, the pole shoes also support the field coils. And the laminate pole cores carry the field windings. It is necessary to produce the flux. And also it directs the flux produced through the air gap. And these two are in the section is the circular section. Regarding the construction, should be a circular section. This part is the sectional view. It is the circular section. Okay. And here the pole core, it may be is made up of cast iron or cast steel. For small machines, cast iron is used. For large machines, cast steel is used. The next part is the pole coils or field coils. These coils, this is the coil, excited coils. These coils are wound in the pole core part. This pole shoes support this coils. This pole core carries this coil. When electric current passes through this coil, then this coil electromagnetize the poles and this pole act as an electromagnet. So this will be the field poles or field. These poles are field poles. These coils may be called as field coils. So you can call this one coil as exciting coil. The next part is the armature. Armature core. It is also a rotating part. And this function of this rotating part is to rotate it rotates the conductors in uniform field. The conductors will be present in this slot, this intermediate place. Okay, so this rotates the conductors in the uniform magnetic field. The magnetic field is produced by the field poles, and then it houses the armature conductors in this place, and also it provides a path of very low reluctance to the flux. Reluctance means opposition of flux. So it provides very low reluctance means it initiates a flux through the armature from north pole to south pole. Here, coming to the construction of armature core, it consists of many segments, laminated segments. This may be a cylindrical or shaped. Here it looks like cylindrical shaped, or it may be a drum shape. Here each segment is for the circular laminations. Several segments are attached. These lines, the scorecard lines represent several laminations and are attached. This is a single piece. This is the slot teeth. Several laminations are attached and then fused into a armature core. This the purpose of laminations are used to reduce the eddy current loss. And here each lamination is split into segments. This is one segment. So likewise it is constructed. The next one is armature windings. So see, this is the armature. Here this is the slots. In the slots the armature windings are wound. So these armature windings are farmer wound. Farmer wound means initially these windings are wound in a rectangular core, and then afterwards it is taken and then wounded in the, it is taken and should be wounded here. Here these coils are insulated from each other and the conductors. These are the slots. This is placed in the slots. Here the next part is the commutator. Here this is the commutator. This commutator collects the current from the generated current. Here generated current from the armature conductor. So here this the commutator. There are many segments. This provides the connection between the rotating armature and the stationary external circuit. Here electrical output, but here in this is the rotating part. So you need an intermediate between the rotating and the stationary. So this commutator provides a connection between the rotating armature and the stationary external circuit. It also converts the alternating current induced in the armature to unidirectional current. Here AC current is produced. So if it is a DC generator, we need unidirectional current DC. So this will convert the AC to DC in the external circuit. And coming to the construction, here the cylindrical structure, this is of wedge shaped copper segments. The shape is wedge. Here these are all of copper segments. These segments are insulated. These lines represent several segments are attached. So several copper segments insulated each other by mica. In between the mica insulation is produced. For large commutators it is mica. For small commutators it is micanite. Here number of armature coils is equal to number of segments. Here this is the copper lug. Each coil is connected to this armature coil is connected to this copper lug. So number of segments will be equal to number of each. Okay, here this is the copper lugs, this point. Here each coil is connected to this lug. And you see this diagram here, the armature coils are connected to the lugs. Here you see each segment mica insulation. This is the copper segment, the shining part, and in between these two mica insulation is present. Here you see clearly this is copper segment wires, armature conductors. Here this is the mica insulation. Here also you can see the lugs clearly. Here this is lug, here armature conductors connected. This is the commutator segments, the mica insulation between these two. This is the shaft. The last part is the brushes and bearings. This is the brush. Here this brush collects the current from commutator and supply to the external load circuit. Here the electric power is generated, it converts to unidirectional, the commutator that is collected by this brush. Here the brushes are attached here. This is commutator, this is armature. See, this is the armature segments each. Here these are all insulations. The slots, this is slots, these are insulated with each other. This is the field poles. First for field pole, here armature slots, this is the brushes, here commutator. So these brushes collect the current from the commutator and transfer to the load. This may be a rectangular shell. It is made up of carbon or graphite or copper. It is housed in box-shaped brush holders, and then the bearings. Here the bearing, this part here bearings. Ball bearings are used for the small machines. For larger machines, roller bearings are used. In the next session, we'll see about the principle of jet.